Getting closer to Tandy assembly at the end of September, so this is part 4 of my restoration of the CoCo 2 with Dungeons and Daggerath for the no minimum bid auction. I need to clean the keyboard. This is what it looked like when we took it out of the box. In the video description below, I link a video where I broke down a melted keyboard and completely cleaned it. So go take a look at that, and then I'll kind of update on a couple years later what I think any changes about that video. All right, so here's the computer with the keyboard all cleaned up. One thing I didn't mention in the video that I definitely wanted to talk about is you really need the right tool if you're going to pull the keyboard up. Remember, I talk in the other video that you can actually pull these keys up, so you may not need to go through everything that video talks about. You might be able to just pull all the keys, clean everything out, maybe with a little alcohol to clear things up, and you're good to go. This is after I finished on this one. Another thing slightly different than a couple of years ago, I did that for the actual keycaps themselves. I tend to use just more mild things than NAPMA. I restored guitar, so NAPMA used to be my go-to thing. I've had no problem with CoCo's, but on some other ones, sometimes they can actually hurt the laser etching of the keys, especially if they were kind of cheaply put on. So sort of start with maybe a little bit of dish soap and water, and clean it and rinse very well. And you can sort of touch up with maybe a rag of alcohol, or test one before you dump every key into a bin of NAPMA or alcohol. But this is all cleaned up. Next step, what I'm going to do is show kind of opening up the CoCo, pulling it down to the CPU board. Now I'm going to upgrade to 64K of memory, so I'll walk through that, but I want to talk about a couple of things that are the way I do it. Number one is I'm going to link in the references. I've already linked the keyboard cleaning video, but how to power your CoCo 2 with USB. You can make a simple cable and plug into a USB-A adapter, the little square connector, and you can power the entire thing except really the serial port with that. This allows kind of working on it like I'm going to, and it's a lot safer. You don't have like the 120 volts going into the power converter. In fact, in the next video, I'm actually going to convert this to, it's already been done, but to USB power, so whoever gets it can run the whole computer on that. That's a little more involved to get the serial port back working, but for I call it the tryout cable, so there'll be a link to that. Also, just in general, introducing this, I want to make sure I'm kind of doing this step by step. I've seen a bunch of CoCo 64K upgrades where what people do is they yank all the memory chips out, throw in all the 64-bit chips in, they do the solder jumper, and then they turn the computer on. In my opinion, this is kind of the wrong way to do it. Even the newer memory chips are kind of like old memory chips too. What I recommend is, and you'll see me go through this, is replace the chips one by one still at 16K. The 64K chip works fine. It's the same pinout, and you can actually swap them so that you get every single one, the 64K in, working at the 16K level, test it, then solder the jumper connection and test it at 64K. Not kind of the big bang testing. That way your day isn't ruined if you end up with one bad chip. In fact, I'm actually, and I linked this as well, going to use the retro chip tester, but that's a huge project to put that together. That took me a long time, but I like it. So I do recommend that, but they kind of send you a board. You have to put about 1,000 parts on it and all of that and get it to work. But I do have that, so I'll kind of show that in action. So we'll get this up to 64K of memory and clean it up. All right, with the case open, flashback to the first video. See kind of how dirty it is inside and dusty. Here's the ROM chips. They're like covered. Obviously, just blowing this out with a air compressor will help. There's some support chips. You can see the keyboard attachment up in the upper left. Here's the memory chips. These are 4517s that we're going to replace. They're not labeled right though. And here's the power switch. So we're going to start with this, with blowing it all out, and then we're going to clean it with 99% ISO alcohol. All right, so this was my attempt to film taking one of the chips out. I'm actually going to pull all the socketed chips. So I kind of use a lever tool to lift them up a bit and then kind of pull them out very carefully so I'm not bending all the pins. Doing this one-handed is pretty much impossible. All right, so I got all the chips out. You can see all the socketed ones. I'm not desoldering stuff here. The computer works. I keep it kind of carefully aligned. Make sure you take a picture of what this looked like before you started if you do this. All right, next I blew off the computer before, but I use a soft toothbrush, dip it in 99% ISO, and I kind of clean everything up carefully around the board. You don't want to be scrubbing here. You're just sort of cleaning up to get everything clean. Okay, that was for all the headphone users. Finally, I used Detoxit on the chips. Check the legs and make sure everything's good, but put a little Detoxit on the legs. You can do this in the sockets too. It's the red kind, not the gold, because these aren't gold connectors. All right. Then this is also hard to do with one hand, so I'll only do one chip, but I've sort of pre-checked this, but I kind of line it up and check that it's in there right, and then I'll just kind of reseat the chip. Right, all done. So this picture gives you an idea what this looks like. If you go back to the beginning where I showed the dusty thing, after kind of blowing it out, cleaning it with ISO and reseating the chips, this is what we sort of got. This looks much, much better. You can even see the keyboard connectors pushed in there, but very clean. I also used Detoxit on the keyboard clean connector down in the lower right in this picture. All right, also toward the center of this, and let's rezoom here, you can see W1, which is what we're going to jumper later after we test all our memory. All right, linked in the video description is how to use a tryout cable to power the CoCo 2 from USB. See, I've got a plus and minus 5 volts connected in, and here I am going to hook it into adapter. My protector fell off, but dealing with 5 volts, it's pretty safe and easier. Click and it comes right on. I don't have a keyboard connected, anything else, it just works. This is a good setup for me to upgrade the memory in the computer safely without the 120 volts like transformer and power adapters causing making this a little safer. Swap out the 64K 1-bit chips one at a time with the old ones, which are 4517s. So this picture kind of sets the stage for why I'm able to do what I'm doing. In the CoCo right now, we have the MCM 4517s, which are 1-bit 16K. If you compare those to the 4164, only one pin is different. There is a no connect on pin 9, which is circled in red, and on the 4164, that's A7. That gives us the extra addressing bit. So we can use 4164s inside the 16-bit K configuration, and that's what I'm going to be testing first before I actually jump the jumper at W1 and make it 64K. Just for fun, I do have a retro chip tester, so we can test our 4164s. I'm kind of showing doing this here. It runs a check on the memory chip. This device is like I said, there's 1,000 parts, and you get a blank board, and you got to put it all together. So it's quite the project to do. If you're handy with a soldering iron, it's not incredibly difficult. But
I'm running it off a 9 volt, which gives it all the different powers, which is far more helpful for Z80 TRS-80s than CoCos, which sort of run under 5 volts. They don't need all the weird powers. You can see it takes a bit. This is not a great thing for if you had to test 1,000 chips, but it did help me. I had a whole bag of 4164s from various places, and I ended up figuring out that a third of them were bad and created a pile of chips. But this one here, I went through each of these on this and tested. They all tested fine, so it was great. And it passed. So we can pull the chip out and save that one. That'll go into the CoCo. Here's the existing memory. I'm going to change out one single 4517, which is sort of popped up because I have to do this with one hand, so I can just lift it off. And put the new 4164, which, as we already talked about, should work fine. So I'm going to push that in. Then I'll use my tryout USB power cable here to actually fire up the CoCo and make sure it sort of still starts up. Not going to run a whole lot of tests at this stage because I've tested the memory, but if it doesn't come up on a screen, that chip is probably not in great shape. And I'm going to do this for each and every one of the 8 memory chips. At this point, I have 6 of the 8 swapped over. Only 2 original chips are in there. Again, just plug it in and see if it works. Comes up. Great. And I'll finish that out. With all the chips changed over from 4517 to 4164, I put the keyboard back on, and I should see the same print mems I did. So if I do a print mem, I get 8487, and if I P clear it, I think I get somewhere in 13K. So this is 16K. Looks like everything's functioning okay. Okay, at this point, I use a little bit of wire and do a solder drop to bridge W1. This changes the computer over from 16K to 64K. I already showed where W1 was earlier. So with the W1 jumper in place, I fire it back up again, and we're going to get some of the memory. It'll definitely go up from the 13K we saw, but BASIC doesn't see all of it. So I do the P clear, and then let's print mem, see what we get. All right, so 29K, it clearly is seeing it. This is maybe not the best test. You can run the diagnostic test program. I have a cartridge from Ian Maverick, but I think if you had a SDC, you could just load this up. And I'm kind of showing it, going through some of this is the video test. So with the 64K, and again, I'm still on the USB power here. I haven't redone the computer. It tests things out. So the memory test can take a while, but when it's done, you should see 64K RAM is complete and RAM is good. So this is successful. So I hope to see you at Tandy Assembly 2024 at the end of September. And remember, this particular computer that's being restored will be in the no minimum bid auction. Take care.